Welcome to this explainer. Okay, let's dive straight into something incredibly cool today. We're looking at a true waste-to-wealth innovation that has the potential to completely revolutionize how we build our cities. We often talk about sustainability as if it's a compromise, right? Like going green somehow means you have to sacrifice structural strength, or you're just gonna have to spend way more money. But the research we're unpacking today, it absolutely flips that narrative right on its head.
Here's a quick look at how we're breaking this down. We'll start with the two big crises facing construction, introduce the green alternative, check out its raw strength, examine the massive market potential, and finish up with the awards it's been raking in. Let's get to it.
Part 1. Two crises, one solution.
So to really get why this matters, we've got to understand the massive dual crisis happening right now in the construction world. On one hand, we're facing the rapid depletion of natural sand. Seriously, after water, sand is the most consumed natural resource on the entire planet, mostly because of concrete production. At the exact same time, the ceramic industry is churning out insane amounts of industrial waste, which is just overflowing in dumping sites. Think about it, we're literally running out of the very thing we need to build, while simultaneously drowning in the waste we're throwing away. The solution here is almost beautifully simple. You just replace that depleting natural sand with recycled ceramic industrial waste in the concrete mix. Boom! Both problems solved at once.
Part 2. The CIWfa green alternative.
So, what is the actual hero of our story today? Let me introduce you to CIWfa. That stands for Ceramic Industrial Waste Fine Aggregate. This is a newly engineered green material alternative, and it was created by a brilliant research team over at University Tun Hussein on Malaysia, or UTHM, led by Mohammed Lutfi B. Ahmed Jenny. This whole thing is the perfect example of the exact paradigm shift we desperately need in manufacturing. It's that waste-to-wealth concept in action. The environmental burden of ceramic waste? No longer a liability. Thanks to this team, it becomes a highly valuable construction asset.
Just check out this side-by-side comparison to see what this looks like in reality. Over on the left, you've got your ordinary, depleting natural sand, and on the right, the CIWfa alternative. Notice how it's been processed and crushed down so it acts exactly like a fine aggregate? It genuinely looks and feels just like the regular material builders are already used to, and that's huge because it means the barrier to entry for actually adopting this on a construction site is practically zero.
Part 3. Unyielding strength and durability. Now, a green product is honestly useless if the building falls down, right? So let's talk performance. CIWfa isn't just some eco-friendly substitute that you have to make excuses for. It brings real, hard technical advantages to the table. Ceramic is inherently a fantastic thermal insulator. Plus, it has refractory properties, meaning it actually retains its strength even at wildly high temperatures, which is a massive safety upgrade if a building ever catches fire. It's incredibly hard, highly durable, and serves as a direct one-to-one replacement for fine aggregate. So yeah, these aren't just environmental perks, they're major technical upgrades.
And we aren't just dealing with theory here. Take a look at these actual concrete block prototypes cast by the UTHM team. This proves it's a tangible, lab-tested reality. They didn't just model this on a laptop somewhere, they physically poured it, cured it, and put it through absolute torture in the lab.
Which brings us to the most important metric, 33.3 newtons per square millimeter. During their compressive strength testing, the researchers found that a concrete mix swapping out just 10% of ordinary sand for CIWfa hit this peak strength at 28 days of curing. To put that into perspective for you, standard grade 30 concrete used in typical construction only requires a strength of 30 newtons per millimeter square. The CIWfa mix didn't just meet the industry standard, it completely beat it. It's demonstrably stronger.
Part 4. Affordable housing market potential.
Okay, so it's stronger and it's greener. Awesome. But what about the cost? This is where the innovation translates into pure commercial viability. CIWfa is laser-targeted at the massive affordable housing sector, specifically the M40 and B40 income brackets, and that market is exploding. The researchers have already identified an entry point of over 2,500 housing developers and north of 21,000 contractors operating in this space. By aligning with the major players, CIWfa positions itself as a totally scalable solution that actually lowers overall construction costs.
Let's look at the actual math here, because the numbers don't lie. If we reconstruct the economics of making standard grade 30 concrete, and we keep wages, machine costs, and profit margins exactly the same, the big variable is the raw material. Ordinary fine aggregate runs about RM 184.000 per kilogram equivalent in this mix. But using the CIWfa material, that drops it to RM 178.00. This definitively proves that sustainable building does not have to come with a premium price tag. Actually, it saves you money.
By bringing the total cost of that grade 30 concrete down to RM $229.90, the UTHM team hit the exact economic tipping point. Think about it. That small margin of savings, multiplied across thousands and thousands of tons of concrete for a housing development, we're talking massive financial savings. That's what makes sustainable, affordable housing a reality for these developers.
And the best part is they aren't trying to push this uphill alone. Having the collaboration and backing of the Construction Industry Development Board, CIWB Malaysia, along with groups like RedHay and JKR, provides a massive layer of credibility. It basically ensures that CIWfa isn't some rogue science experiment. It's a fully compliant, market-ready material backed by the absolute heavyweights of the national construction industry.
Part 5. An award-winning innovation. Finally, let's look at how the wider scientific and innovation communities have reacted to this. Now, before taking this on the award circuit or to market, the team played it super smart. They secured their intellectual property. CIWF is officially commercially protected and registered with the MyIPO copyright. So all their hard work developing this waste-to-wealth tech is totally locked down as they scale it for commercial use. Once it was protected, the accolades just started pouring in. Securing this prestigious gold award at iCompax and RETEC completely shuts down any skepticism about its scientific validity. Expert judges analyzed the data, tested the concrete, and officially declared it a top-tier innovation.
And the recognition definitely didn't stop there. It snagged a silver award at the International Invention and Innovative Competition as well. Every single one of these awards acts as a peer-reviewed stamp of approval from the scientific community.
And just for good measure, here's even more validation. Yet another silver award, this time at Innovation Day Nuclear Malaysia, with multiple independent awards from highly esteemed institutions. CIWFA's is undeniably proven. The data is real, the strength is real, and those economic benefits are absolutely real.
Which brings us to our final thought for today. When you're looking at a material that cleans up industrial dumping sites, preserves our natural beaches and rivers, builds stronger walls, and literally costs less money, the only question we should be asking is, why aren't we building every city of the future with this right now? Thank you so much for joining me for this explainer. Keep learning, keep questioning, and I'll catch you in the next one.